Hello guys, so today we will see an image comparison algorithm based on image processing, and we are using OpenCV. Okay, so we have a small data set of wallpaper images, and we have some crops of these images as well. So you can see this is how the data set looks like, and some other random images. Okay, so our task is to map the crops with the original images. Okay, so we will use an image comparison algorithm and rely on the CV2. This is the script of to compare them and generate similar images. Okay, so we will see that. So first of all, I have imported some libraries, mostly using CV2 and NumPy, and the iter rules for generating a list of comparisons. Okay, then we have some helper functions. Okay, then we have created a data set, also importing our images. Okay, so I have currently distributed in three different folders. Desktop folder having original images, mobile folder is having some crops of this desktop images, and then some unpaired images as well. So we will combine in this image paths list. Okay, then we will initialize some variables over here. So first of all is output directory. So then we have some threshold values, so it will help us to how strictly our comparison will be. You can tweak these values according to your use case. Okay, then we have initialized some supporter objects over here. Then we will creating CV2 images of each image in our image path list. Okay, so it is same as the numpy array. Okay, so numpy arrays of three dimensions because we have colored images. Okay, RGB layers over there, and we combine in a list called images. Okay, then we have created a descriptors list of the descriptors object for each image in the images list. Okay, so the descriptor object is also an numpy array, but it is a two-dimensional numpy array having the feature coordinates from the uh, original image. Okay, so it is known as a feature array. Most probably it will be the shape of 500 by 32. Okay, default shape is 500 by 32. So that is why we will take the comparison range between 0 to 500 only. Okay, so you can tweak those values according to your use case further. So then we will create our output directly before going to our for loop. Okay, then we will create some permutation indexes for comparing each image to another image in the data set with this image path. So it will generate some permutations of the indexes. Then we will pass the descriptors of the index to the match function, and match function will give us the exact matches for the two images that we have given. Okay, for the two descriptors that we have given, and by looking the length of the match counts, we will filter out the images. So based on there, the range is between 0 to 500. So in this range, 0 to 50 will be the different images. Okay, then the range of 50 to 150 will be looking like similar image, and the range final range of 500 to 150 to 500 will be the same images. Okay, so currently I have choose similar images. Okay, so output directory is similar, and the range is of 50 to 150. So whatever the match count will 50 to 150, then it will put those images in the similar folder. Okay, so we'll run this. So you can see the similar uh, folder has been created, and all those comparison images will be putting it over here. So you will see all the similar images over here. It will look like now, like you can see the top of the image and the original image has been uh, linked together, right? So this is how you can find the similar images, and same as the same image. So we will have same folder, and we will create another range of 500, and we will simply run it. It will create another folder named the same, and it will put the same images over there. So you can see our folder is created and putting some images over there. So you can see it is look like that. Whatever the same images, it will be found in the data set, and it will just put it all here. So yeah, that's the case. This is how we can compare two images you can have any kind of shapes over there, so it will doesn't depend on the shape of the comparison images. So you can add any shape of images if they don't have the same shape. As you can see over the desktop images and mobile images doesn't have the same shape, still we can generate a good enough accurate results. So it will be good working algorithm. Yeah, thank you.